Hi everyone, welcome to all of you on my YouTube channel. I am Ankit Mishra. I am teaching for GATE Chemistry from last 5 years. Here is the revision series of chemical technology for the chemical engineering. So I will start with the petroleum refining here, and already I have discussed the petrochemicals and petrochemicals industry, sulfuric acid production industry, nitric acid production industry, all of these. So let's start with the petroleum refining. So here you can see on my screen that when I am talking about the petroleum refining, the petroleum refining industry works on the crude oil that works as a raw materials for this thing. So crude oil is a mixture of various components, and at least you can see there is 8 component that is present in the crude oil, and this crude oil contains carbon is in abundant quantity. Carbon and hydrogen is the major component of the crude oil, and after that obviously sulfur, oxygen and nitrogen and another elements are also present in that. So when I am talking about the crude oil, so olefin, naphthalene, naphthalene and aromatics, all of these are the components of the crude oil. So here you start with the olefin. So here you can see, so olefin generally possess unsaturation compound that is like alkene, ethylene, propylene, butylene, all of these things, and they are not found in measurable quantity in crude oil, right? So this is one component of the crude oil. Second one is naphthalene. So here you can see that a cyclic compound that is called as naphthalene without double bond characteristics, right? So that is called as naphthalene, that also contains a significant part of the crude oil, and these compounds are not aromatic. This is not aromatic, hence do not contribute much to the octane number, right? So later on I will discuss about the octane number. There you will understand what is the importance of aromatic compound in increasing the octane number of the crude oil. Okay, and the next compound is aromatic and naphthalene. So aromatic is you can say that is a kind of ring kind of a structure where it is a double bond, right? So benzene, xylene, toluene, all of these compounds come under aromatic, and naphthalene, then this is a polynuclear aromatic such as naphthalene, and here you can see minimum 2 rings will be there, and in 2 rings you will be having a double bond characteristic. So when I am talking about aromatics and naphthalene, that contribute to increase in octane number of the petroleum or petroleum product. Now coming to the some characteristics of the fuels in petroleum refining, that is the flash point. So here you can see that it is the minimum temperature. So you have to understand the minimum temperature, right? So this is the minimum temperature at which the crude oil gives sufficient vapor to produce instantaneous flash is called as the flash point, right? So let's say if flash is going to sustain for 5 minutes, then that will be called as the fire point, and generally fire point is 4 to 5 times greater than the flash point, right? So these both points indicates the suitability, suitable characteristics of the temperature dependency of crude oil, whether up to what temperature, up to minimum temperature we can store the crude oil, something like that, and they indicate the temperature up to which the fuels can be used safely. That is very, very important. Next is cloud point. So this the definition is that the minimum temperature at which the oil becomes cloudy or hazy on cooling is called the cloud point. So let's say when you decrease the temperature, what will happen? Due to decrement in the temperature, the oil will start becoming cloudy or hazy. So that point will be called as the cloud point. So again, this is minimum temperature, right? Because temperature you are decreasing. So this will tell you that the minimum temperature from which you can you can start using the crude oil, right? So below this you cannot use. Now coming to the next is pour point, where you can see that when the oil is cooled first, it becomes heavy, and on further cooling it just stops to flow, right? So the flow of oil will stop there. So the minimum temperature at which the flow of oil will stop, that is called as the pour point, and the pour point is generally lesser than cloud point by 4 to 5 degrees centigrade. So this is lower than the pour point. So sometimes they can ask you a relation between cloud point and pour point. So pour point will be cloud point minus 4 to 5 degrees centigrade. That you should know. Okay. Now coming to the next, that is very important characteristic that I have already I talked in the last slide there, octane number. This is very important characteristics of the petrol engine, and it is expressed in the spark ignition and knocking characteristics, right? So higher octane number is preferable for petrol, and the octane number is defined as the percentage volume of isooctane and by isooctane plus n-octane. So this is the percentage volume. So in questions they can give you the volume of mixture of isooctane and n-octane, and from there you can calculate the value of isooctane. So now if you see the order of octane number of various compound which is present in the crude oil, that is aromatic, isoparaffinic, olefinic, naphthalene and paraffin, right? So these are the orders. So this order is very important. Generally get asked this question, right? Now coming to the C10 number, so this is the characteristics property of the diesel engine. It facilitates the easy start of the diesel engine, right? So C10 number is defined as the percentage volume of NC10 divided by percentage volume of NC10 plus alpha methyl naphthalene, right? So when I'm talking about the C10 number of NC10, that is 100, and the percentage C10 number of alpha methyl naphthalene, generally it used to be 0. So when you calculate this value, it will give you the C10, and you can see this alpha methyl naphthalene is something like methyl group is getting added on the naphthalene ring on the alpha position. That's why this is called as alpha methyl naphthalene. Now coming to the smoke point, so this is the characteristics property of the kerosene. So you have to remember these things also, which point defines which kind of fuel. So C10 defines diesel, octane defines gasoline or petrol, a smoke point defines your these things, kerosene, right? So higher the smoke point, higher is the quality of the kerosene. Means if a smoke point is higher, then the kerosene will burn without producing any kind of a smoke, and that is very much desirable for the kerosene, right? So a smoke point is defined as the sample of kerosene burned in a standard flame for 5 minutes without leaving any smoking trail, right? So a smoke should not be generated when you are burning the kerosene. So if a smoke is getting generated as soon as eventually or at the very start of the burning, then that kerosene is not good for as a fuel. So the height of the flame in which called a smoke point, and generally good quality of a smoke point should be good quality of kerosene should be having a smoke point around 25 millimeter, right? That is it. So higher aromatic content, lower will be a smoke point, means aromatic content is desirable or aromatic component is undesirable for the kerosene. That's why if aromatic content is more, then definitely it is going to produce more and more smoke, that is undesirable for the kerosene, right? So you have to remember this thing. So the order of the smoke point will be like the opposite of the order of this thing that you have studied, right? So you can relate this thing from here. So aromatic was very much desirable in gasoline, but aromatic was very much undesirable in kerosene. So if you reverse this order, then that will be the order of the smoke point of this particular fuel, right? Now coming to the next point, that is aniline point. So this aniline point says that it is the lowest temperature at which the equal volume of oil is completely miscible with the equal volume of aniline, right? So aniline is a kind of aromatic compound. So this will give you the criteria of how much aromatic content is there in the fuel, right? So it is measure of aromatic content of an oil, and more is the aniline point, means more is the aniline point means lesser content of aromatics is there, and the aromatic content of oil will be very less. So if aromatic content is less, then you can say that octane number will be very less. So if aniline point is high, octane number will be less, right? So you can correlate aniline point with the octane number also. Coming to the acid number, so acid number is defined as the milligram of KOH required to neutralize the free acid present in 1 gram of an oil. And let's say if in 1 milligram of oil, how much free acid is there, and if you want to neutralize the free acid by using KOH, so the number of milligram of KOH required is called as the acid number. So you have to understand, in option they can give you the number of milli equivalent, number of equivalent, all of these things, but all of that options will be wrong. Here you can say that number of milligrams of KOH that is required to neutralize the free acid present in 1 gram of oil. So it determines the acidity of the oil, and higher acid number indicates sludge formation and corrosion problem. Obviously, if acid number is more, then definitely you will require large number of alkali to neutralize that thing. So higher sludge formations will be there, and higher corrosion will be there. So that oil will be very less corrosion resistant. Acid number should be less than 0.1%. That is the maximum criteria for acid number. Now coming to the calorific value, because ultimately if we are using any fuel, then the fuel is used for energy production, right? So here you can see that calorific value defines the energy of that is related to energy production of the fuel. That can be defined as the total heat produced per unit mass of fuel completely burned with pure oxygen, and this can be defined as, so pure oxygen will be there. So in option you have to remember that pure oxygen, so fuels are burning in complete oxygen condition, means there is no possibility of carbon monoxide formation. Due to complete combustion, CO2 formation will be there, and this is divided into two parts, that is gross calorific value and net calorific value. So in gross calorific value, you can see the definition is only important here. It is the amount of heat released by complete combustion of unit mass of the gas, right? and it is also called as a higher heating value, right? And then net calorific value, so it is obtained by subtracting heat of vaporization of water from gross calorific value. So you can say that net calorific value will be equal to GCV, gross calorific value, minus the latent heat of vaporization of water, right? That will be given to you in the problem, and from there you can calculate the net calorific value from gross calorific value, right? Now coming to the petroleum cracking, or cracking is very important reaction, and generally in cracking what will you do? So you are going to heat high boiling petroleum fraction at higher temperature and pressure to produce lower boiling petroleum fraction, right? That is breaking of a long molecule into a smaller one by heating it. So it is used to produce a smaller molecule from larger one like gasoline and olefin, etc. And the temperature here you can see is 400. There are two kinds of cracking: thermal cracking and catalytic cracking. So obviously in thermal cracking you will require higher temperature and higher pressure. In catalytic cracking you will require temperature and pressure less than compared to the thermal cracking. So here you can see that thermal cracking is carried out at a higher temperature, that is 450 to 700 degrees centigrade, and higher pressure 1 to 70 atm. While for catalytic cracking the temperature required is 350 to 700 degrees centigrade and the pressure is 1 to 15 atm only. So in catalytic cracking you can see the catalyst that is being used is zeolite, that is very important catalyst, silica and aluminium and natural clay. So from here they can ask you how many kind of cracking are there, thermal and catalytic cracking, and what is the criteria, temperature and pressure criteria for thermal and catalytic cracking. So you can differentiate that thermal cracking definitely is going to require larger temperature or higher temperature compared to the catalytic cracking, and both temperature and pressure condition for the thermal cracking and is more compared to the catalytic. And the catalyst used in the catalytic cracking is silica and obviously zeolite, alumina and natural clay. Okay. Now coming to the fluid catalytic cracking and hydrocracking. So this is also very important. Generally get asked objectives on this MCQ. So in fluid catalytic cracking unit, it requires two units working simultaneously. So there you will be having a regenerator and a reactor. So in reactor then generally endothermic reaction is happening, and in regenerator this is exothermic reaction. So the endothermic reaction that requires heat can be fulfilled by the heat released by the exothermic reaction that is happening in the regenerator, right? So the basic principle of FCC unit is fluidization of catalyst, and catalytic regenerator is required to regenerate the catalyst by burning coke into the air, right? That is very important. So here two important things are there: regenerator and reactor. Regenerator, in regenerator reaction taking place is endothermic, and reactor reaction is happening in the endothermic process, and in regenerator that is exothermic process. Okay. Now coming to the hydrocracking. So in hydrocracking you can say that cracking in presence of hydrogen is called a hydrocracking, and obviously catalyst here used in the vapor phase is tungsten sulfide, and in liquid phase the iron is used as a catalyst, and the temperature and pressure is 400 to 500 degrees centigrade and 70 to 700 atm pressure, right? So hydrocracking, again here you are cracking the larger or higher molecules into the lower molecules. Coming to the hydrotreating, so it is used to remove impurities like sulfur, oxygen, nitrogen, etc. And it is possible because higher amount of hydrogen you are supplying, because hydrotreating is the process. And in order to sterilize the petroleum, this process also sterilizes the petroleum, and also you are removing sulfur, nitrogen and oxygen compound that is there in the crude oil, and which is going to decrease, which is ultimately decreasing the GCV, gross calorific value of the fuels. The temperature and pressure is 300 to 350 degrees centigrade and 15 to 17 atm. The catalyst for this process is cobalt molybdenum, that is very important catalyst. The catalyst that is used in the hydrotreating process is cobalt and molybdenum. Generally it removes H2S. H2S is being recovered and sent to the contact process for the production of H2SO4. So the contact process is industrial process which is used for the production of H2SO4, contact, double absorption and lid chamber process, right? Coming to the reforming, this is also very important properties and methods to improve the properties of the gasoline. So reforming means changing the element of the molecules without changing in the molecular weight. So generally you are rearranging the molecules and you are not going to remove or change this things. Cracking is not there. Cracking and reforming is different. In reforming, molecular weight will be as it is, right? And generally this happens in three form: fixed bed, fluidized bed and moving bed. Coming to the polymerization, this is also very important reaction. Mostly the question is being asked here is catalyst. The catalyst which is being used in polymerization is your S3PO4. Okay, and gaseous product is that are rich in olefin, and this gases undergo polymerization in presence of phosphoric acid, that is SO4, that works as a catalyst. to give a branch and polymers. So olefin is getting converted to branching. So branching increases the quality of the gasoline, right? So as for example, 2-isobutene undergoes polymerization to form di-isobutene, which is a branch and polymer. Its main aim is to increase the branching. So why we are doing the polymerization? To increase the branching. Now coming to the alkylation, this is also very important process in petroleum refinery. So you can see that alkylation means reaction of olefin with paraffin or its aromatic. So the reaction takes place in presence of sulfuric acid. The catalyst being used here is sulfuric acid and or hydrofluoric acid HF. Its main aim is to produce larger isoparaffin having higher octane number, as for example isobutene plus and butene. So only two things that can be asked, that why we are doing these things. We are doing these things to convert the normal butane to isobutene, right? And catalyst used is H2SO4 or HF. Coming to the isomerization, the aim is to convert normal paraffin into isoparaffin, because isoparaffin's octane number will be more compared to the normal, right? So we are generally isomerizing the thing, and the catalyst that is being used in this particular process is AlCl3, aluminum trichloride. And once you isomerize n butane into isobutane, it will increase the octane number also. Now coming to the sweeting process, sweeting process is the process of removal of sulfur compound like H2S and mercaptan from the petroleum product. And there are 5 different kind of sweeting process that you can see here. That is Doppler sweeting process, copper chloride sweeting process, solutizer process, catalytic desulfurization, and hydrofining process. So first I will start with the late Doppler process. So the only one thing that can be asked from here is what kind of compound that is being used to remove the sulfur compound from here is sodium plumbite Na2PbO2, and here you can see that sulfur is getting removed from the petroleum product. Next is copper chloride process. Here generally CaCl2 is being used to remove the sulfur from the petroleum product, right? So the compound can be asked that CaCl2 is copper chloride, and Na2PbO2 is used in the late Doppler process. Now next is solutizer process. This is very important process. So in this process you can see this requires solute for removing sulfur from sour gasoline to convert into the sweet gasoline, right? So when methanol is used as a solute, then it is called as the unisol process, and when naphthenic acid is used here, then it is called as the mercaptan process. Okay, I hope this is clear to all of you. Now we will be moving towards next process of sweeting, that is catalytic desulfurization. So in this process generally whole molecule containing sulfur is not going to remove, so only you are focusing on the sulfur atom which is being picked and thrown out. So due to this particular process there is a negligible loss of material, right? And recovery of sulfur is also very good. And the catalyst that is used here is transition metal. That is very important. The catalyst in catalytic desulfurization unit is very important. That is the transition metal. And here generally atom of the sulfur is being removed, not the whole molecule, right? Now coming to the Bertillier's process. So here in this process generally what is happening, the finally powdered coal is made into paste with heavy oil and then heated to 400 to 800 degrees centigrade under 200 to 250 atm pressure in presence of organic compound, and the catalyst which is used in the Bertillier's process is same. So then it followed by cracking and dehydrogenation to give gasoline, higher yield of gasoline, mid oil and heavy oil. So the product that is being formed here is higher yield of gasoline, mid oil and heavy oil, and the catalyst that is used here is steam. Next is Fischer-Tropsch process. That is also very important process for petroleum refining. So here you can see in this method involves conversion of coal into water gas, right, with the help of water at 1200 centigrade. So coal will react with water at 1200 centigrade. This will produce CO plus H2, and this mixture is not called synthesis gas. As synthesis gas means that ratio of CO and H2 will be in the ratio of 1:2. So CO is to H2 is 1:1, then that is called as water gas. And if CO and H2 ratio is 1:2, then that is called as a synthesis gas, right? Now a part of CO is removed and converted into CO2. So you can see that a part of this CO that is being formed in Fischer-Tropsch process is removed, and it will again react with H2O in presence of iron catalyst, and it will form the CO2 and H2O. So in Bertillier's process catalyst used is steam. In Fischer-Tropsch process catalyst used is iron, and you can see that here you are producing a water gas, right, not synthesis gas. Next is the very important thing, that is the composition of various fuels. So here you can see that we have natural gas, coke oven gas, water gas and producer gas. And in natural gas, you can see that methane percentage is very high. In coke oven gas, major component is H2 and CH4. In water gas, major component is U and H2. Obviously, I have told you. And in water gas, this is in the ratio of 1:2, H2 and CO. And H2 is to CO is 2:1. And in producer gas, the major component is carbon monoxide and N2, that is 51% and 27%. Now, coming to the next part, this is very important, and they can ask you the order of the calorific value of the compound, that is natural gas is greater than coke oven gas, carbohydrate gas, water natural gas, and producer gas. So carbohydrate gas is obtained by atomizing oil spraying on the water gas, right? So if you want to remember the order, you can write that while you can use this mnemonic, that never cook, carbs with passions, means never is natural gas, cook is coke oven gas, carbs is carbohydrate and natural gas, with is water gas, and passions like your producer gas. So with that you can remember this particular thing, and here I am going to end this lecture here only. That completes the lecture of petroleum refining. Okay, thank you. See you in the next lecture.